Hello everyone, welcome to my YouTube channel. My name is Himanshu Singh, and in this RAG, multi-modal RAG playlist, we are going to talk about VisRAG today. So this particular research paper came out very recent, I think on 14th of October. So they were using a different kind of technique to deal with the multimodality, right? When you have images, text, and tables and charts and everything on your unstructured data, right? So let's talk about that. If I talk about the research paper, this came out like this. Okay, so here they were mostly using two parts, right? You have retrieval and you have generation methods. And when we talk about the retrieval and generation methods, they are using the different kind of formulas, different kind of models for that. And for the generation as well, they are using different techniques like page concatenation, weighted selection, and different methods as well. So today's video, we are going to deep dive on this research paper, as well as we'll talk about more in terms of VisRAG itself, how it's working internally. So this is the architecture of VisRAG. If I talk about a normal text RAG, we have this traditional method where you are just uploading your page text and it is going to be uh, stored on the vector DB. When you query something, that text will be retrieved and it would be given to the RAG generation part, and it would be generating this information, right? So this is your query, right? This is your query. This is the kind of database you have. You ask this, you got the retrieved chunk, and you got the generated answer like this. But what is the case when you have images or this kind of uh, brief, or you can say medical images where there is some context in the image itself, right? What is the trend in the sound frequency sensitivity from the base to the apex of the cochlea? So when you ask this question, and when you have already the kind of vector store, right, like this is called a VisRAG. When you ask this thing, right, your image data and indexes are there. It will be searched in this particular vector database, and it will retrieve this kind of chunk while extracting the meaning from the context. Okay, and the context would be aligned to the image itself, and then it is using kind of VisRAG generation to generate, right? The answer like is decreasing. So in this, we are not getting any answer, but here we are getting, right? So, but what is the difference? What is the difference between the text RAG and the VisRAG here? Is like this. So the pipeline, I'll talk about the pipeline, whole pipeline about this VisRAG is, they are using the different like methods, which is somewhere different from the other methods. That is document parsing method. If we talk about the first method is document parsing method. So OCR approach and captioner approach, two approaches are here. So OCR, you know, right? What is OCR? When you use OCR, you try to grab the text from the scanned PDF or any kind of PDFs or any kind of images like that, right? So it is using PP OCR, like a pedal OCR itself, to identify text aligned on that particular document. It will create the kind of boundary boxes or layout detection it will be doing, and from that layout itself, it will grab the meaning or just context, or you can say that text from the regions itself. Okay, combine vertical alignment and horizontal proximate text boxes to reduce the fragmentation. Like there's some condition they are using to align the, like let's say two boxes are there, so it will use some condition to make it into one box itself, and it will grab all the details from the image itself. Captioner approach apply mini CPM 2.0 fine-tuned on the pair document. So mini CPM, maybe you know about this model. So they have fine-tuned this model, mini CPM version 2.0, using some Siglif 400 models. So what this will do, this will it will apply to those particular chunks and image and extract and whatever the image and extracted text are there, right? So they will directly pass text from the document images using the end-to-end model. They will give to this that particular data to the mini CPM 2.0, right? So parsing is there, then this data will be given to the 2.0 for the captioning itself. Then we come to the retrieval part. What is this retrieval part here? You know, every RAG solution have two parts mostly, like an overview itself, like a retrieval and generation. So when we do the retrieval part, like VisRAG ret overview, what is that? Aims to retrieve and set off pages from the corpus D given query Q. So let's say whenever you ask some query, it will go and it will find the relevant chunks, right? That's a traditional way. Okay. But for that, they are using the dual encoder paradigm. Okay, paradigm for the text-based dense retrieval. Uses vision VLM instead of LLM to encode both query and pages. So we are using kind of LLMs to encode that query in the traditional, but here they are using VLM to encode their query and encode their uh, pages images itself, right? So and what is the process of the encoding? So when you have query, you have page, and both will be separately encoded, right, as in text and image in the VLM. So VLM is capable of encoding your text, encoding your images as well. So it will do that. Okay. VLM produces a sequence of hidden state for both query and pages. The both is being created. Now embedding calculation will be happening. Apply positional weighted mean pooling over last layer VLM state. So this is the formula which is being used to create or calculate the embedding itself, right? So sigma of I equals to 1 to S and Wi into Hi. What is that Hi? Hi is the ith hidden state, right? And Wi is the weight for the ith token. Okay, and S is the sequence length. What is the length of the sequence itself? And V will be your final embedding. So this particular formula is being used to create the embedding. Okay, so let's say once the embedding is created, right, that is the one formal way that embedding is created, and it would be stored on the ActorDB. Now we have this similarity calculation. How we will be getting to know like what is the similarity between your query and the page embeddings. So what this will do, this will do some kind of optimization, right? And that optimization is somewhere follow this loss function. Okay, so this loss function is nothing, it's a log loss only. Formula is different, like they are using kind of um, log of exponential s of q into d plus 1, like that, right? So I I took this formula from this research paper only, right? If you see this one, where D plus is the D minus are positive documents and the negative documents, whatever the chunks it has retrieved, right? For that particular query itself. And SQD is the similarity score between Q and D, whatever the query you have and whatever the document you have. And this theta is the temperature value that is now which will be ranging from 0 to 1, right? So this is how you will be able to optimize your retrieved chunk embedding itself. Like this is what chunk is our the most relevant chunk itself, right? So once you retrieved uh, all the chunks, right? What is happening? Let's say you got kind of uh, pages, right? In some cases you will be getting one page. In some cases you will be getting two pages. In some cases you are getting three pages. So when we were using Pali at that time, we have only one model, that is GPT-4o, which was capable of handling multiple images, right? But what happens if we are not able to use the GPT-4o model? Then this model is capable of doing that thing. This VisRAG or vision based RAG solution. This is able to do that. How it will be able to do that? Like it is using the different methods to work on the different pages images, right? So if I talk about how it handles the multiple retrieved pages, so it do the page concatenation. Like you have n number of pages you got from the retrieval. Now it will do the weighted selection, generate answers from the top k pages, and then select one with the highest confidence score. That would be the okay. Confidence is based on the weightage generation probability of the answer. Means apart from getting the answers, it will be getting the weightage also, like probability also. What is the probability of being that answer correct with respect to this query and this context, right? So that would be your weightage selection. So now it would give that VLMs accepting multiple images. So what they did, they have used this mini CPM 2.6 version, which is capable of handling the more, you can say, or multiple images, And Quinn VL2 is also able to handle the multiple images input. Okay, so if I talk about the model involved here, so mini CPM, it's a large language model with 2.4 billion parameters used for baseline text-based retrieval and generation. SIGLIP is a clip-style multimodal for aligning text and vision. We can use SIGLIP 400 model with flash attention, 980 cross 980 max resolution, and this particular model is somewhere used in Kolpali as well. If you have uh, looked into my last video, which was on based on the Kolpali based multimodal RAG, there we have talked about like Siglip is being used there as well, right? And here they have just fine-tuned Siglip model, and they have used mini CPM model and Siglip model. They have fine-tuned it. They make it mini CPM 2.0. Mini CPM 2.0 is somewhere more like it's a very capable. It's you can say it's a multi-model. You can compare it with the GPT-4 vision as well, right? And this is a Hugging Face library for that. You can go ahead and you can use this model as well if you want, right? You can directly download it from here and you can use it. This is the link of this model I can share with you. Okay, and then mini CPM 2.6. 2.6 they again use like a Llama 2. What they did is upgraded 2.0 and mini CPM Llama 3. There's two models, 3V, right? So they have used this model and they have kind of fine-tuned this model, upgraded it so that it can accept the multiple images and support the multimodality in the context of learning, right? So it has like strong capabilities. 2.6, when we say multimodal, right, this means it has the capability of OCR, it has the capability of kind of generating the answer, taking the inputs, various images and giving you as an output, right, and a text as an image. But till now I don't see any model which is capable of generating it is able to generate the images, but let's say if you have given some images and you want that model can change something on the image and edit something on the image and it can give you that image and the response. So I don't see any model present currently on the market, but yeah, there are models available which can generate the images using some prompts, which can give you the summary or give you the answers for your kind of questions from the image itself. There are the models available, right? That's called the multi-modal only. So that's all about the theory of VisRAG, okay, vision-based RAG system. And this is the research paper. I'll drop the link of this research paper as well as in the next videos, I'll talk about a VisRAG pipeline, right? I have created a kind of VisRAG pipeline on my Google Colab. So I'll show you that how you can use it code wise. Also, I'll try to show you a particular platform of Hugging Face test where this particular model is being deployed, and you can go ahead. You can upload your document there, and you can get you can get the retrieved chunks by doing some queries, and you can generate the answers as well. So I'll show you that as well in the next couple of videos, right? So yeah, that's all about this video. That's for the quick introduction. Yeah, so please do like this particular video and subscribe to our YouTube channel.